This is 6-1 to 6-3 review. Calculators are not allowed. And this is number 5, part C. So we want to again find the volume of the solid generated if the shape is rotated about the y-axis. So boundaries this time are the y-axis. We got another root curve. And we got a line y equals 4. Actually, I think this one, well, close enough. It's going to be some sort of a root. So we need y to be 4, so 4 will equal the square root of 2x cubed. That means I'll square both sides. So 16 equals 2x cubed. Divide by 2, we get 8 equals x cubed, so that's going to happen when x is 2 and y is 4. And actually I'm going to put that up here because I'm going to do washers first, which will be a horizontal slice. So I got a 0, 0 and a 0, 4. So here's my region, and I need to be rotating about the y-axis. So my slice is going to be horizontal. They share a y-coordinate, so the x-coordinate on the left is 0, the x-coordinate on the right is going to come from isolating x on this curve. So I will have a y over 2, then I'm going to square it, and then I'm going to, no, actually I'm going to square first. I lied. I'll square first, then I'll divide by 2, then I'll take the cube root. So this is the cube root of y squared over 2, comma y. Now when I rotate that, I'm going to get a disk, not a washer, because the inner radius is 0. I have a thickness of dx, dy, excuse me, and that radius length is this minus this, so a cube root of y squared over 2. And when I set up my integral, I get the volume is a pi times the integral of that big radius squared. So I have a y squared over 2 to the 2/3. This is a 1/3, so then we square, we get a 2/3 dy. And let's see, we will go from 0 up to 4. Those are my y values. So now, before I do the antiderivative of this, I'm going to pull that constant out. So it looks like I've got a pi, and then I'm going to have a 1 over 2 to the 2/3. So that's a 1 over the cube root of 4. And then inside, I'm going to have a y squared to the 2/3. That's a y to the 4/3. So now I'm ready to answer the question posed by the symbol. That is y to the 7/3 divided by 7/3. That's the same as multiplying by 3/7, and I'm accumulating from 0 to 4. So I would plug in the 4 first. So I'll have a pi over, I think since I'm going to be plugging in 4s and I have a 4 down here, I might just rewrite that with the power. So that's 4 to the 1/3, and then I have a 3 times a 4 to the 7/3, and on the bottom I have a 7. Then I'll subtract 0. So let's simplify this. A 4 to the 7/3 over a 4 to the 1/3. I'm going to subtract those exponents, so I'll get 4 to the 6/3, which is actually a 4 squared. So I have a 4 squared, which is 16, over 7, so I end up with 48 pi over 7. So that's method 1. The other method is to do the same shape, same picture, only we're going to cut parallel to the y-axis. So let me draw that picture again. Got the 2, 4, the 0, 0, the 0, 4, rotating around the y-axis. This time we're going to cut vertically. So the x-coordinate is the same. Y-coordinate on the top is a 4. Y-coordinate on the bottom is that curve. So now when I rotate that, the height will be a 4 minus that root. That's the length of my strip. And I'm rotating around that y-axis so I can find the distance between the strip and the axis by looking at either that point. Well, that's probably the easiest one, so it'll be an x minus a 0. So my radius is just x. So now I can set up my integral, which will be a 2 pi this time times the integral of the radius times the height times a dx, and we want x to go from 0 to 2. So let's get all the constants out in front and distribute. Looks like I'm going to have a 4x minus, that's a root 2 times, I've got an x to the 3 halves times another x, that's an x to the 5 halves. So antiderivative, what did I take the derivative of with respect to x? That gave me 4x. Well, that's a 4x squared over 2 minus, move through the constant. This one I need to add 1 to the power and divide by that power, which is the same as multiplying by 2/7. And this is evaluated from 0 to 2. So the first thing I'll plug in is the 2. So this is a 2x squared, so that's going to give me an 8 minus a root 2 times a 2 to the 7 halves times a 2 all over a 7. Well, looking at that, that's a 2, and the 0 doesn't give me anything, so I didn't subtract anything. If I do 2 to the 1 half times 2 to the 7 halves, that's 2 to the 8 halves, because you add those exponents, which is 2 to the 4th, and 2 to the 4th is a 16 times 2 gives me 32. So I have a 2 pi times an 8 minus a 32/7. So let's get another 7 on here, and I'll have, oops, excuse me, that's a 7. Don't know why I wrote a 5. So I'll have a 56 minus a 32 times a 2 pi. That's going to give me a 48 pi over 7.